All right, so what we're going to do today is kind of go off of the baking analogies from our previous class in terms of relating quantities of different things to one another. And we use recipes to use as an analogy because it gives us a good quantity to quantity ratio between any ingredients that we need or that in relation to each other, right? So, in terms of this, we're talking about a smoothie recipe, and we see how many of each ingredient we need in order to produce the correct yield, so the amount of the product that we're looking for, which is a smoothie. And if we don't have those correct ingredients, then we can't expect to have the correct product nor the correct amount of that product in the end. So for something like this, we use this little colon here as a ratio signifier, and this would be like 4 cups of strawberries is to a certain amount of smoothies. So this is just a ratio. This signifies the ratio there. So 4 cups of strawberries, well, we look, 4 cups of strawberries, and we're talking about smoothies here, is going to be able to produce 1 smoothie. We can go, doesn't matter what order, right? And we say, okay, well, for 1 smoothie, how many cups of bananas would we need? Again, we refer to the recipe as it was originally. We get 2 cups of bananas there. So again, chefs and bakers use this. Anybody with a recipe is doing these ratios and looking at how much of one thing I need in relation to something else. So if we had 8 cups of strawberries, so let's do 8 cup of strawberries. How many smoothies could we make? Again, a lot of these are very straightforward when we're talking about these actual simplified or oversimplified recipes, but we're going to do the process that we've done in class in terms of unit cancellation, because really strawberries, bananas, yogurt, smoothie, those are all units. They're just not units that we're familiar with in terms of like milliliters or grams or something like that. So we're going to start off with what we're given, which is 8 cups of strawberries. We want to figure out how many smoothies we can get in the end. And then, so what I have to do is I have to figure out what is a bridge between strawberries and smoothies, right? And that bridge is going to come from the recipe. So it comes from the recipe. And so I look and I say, okay, well, what equates this? So the bridge here is going to represent this right here, this step. And so we know that cups of strawberry have to go on the bottom here to cancel out as a unit. And we know smoothie goes on top. And we look at our recipe, which is this right here. And we say, okay, well, compare strawberries to smoothies, right? What are those values? I know that for every 4 cups of strawberries I can make 1 full smoothie. So if I had 8 cups of strawberries, that would allow me to then 8 divided by 4 produce 2 smoothies. Of course, we are assuming that we would have the correct amount of all of the other ingredients in order to get to that point. And we'll talk about that a little bit later this unit. But for now, just being able to go from one thing to another is what we're worried about here. So we can go backwards too. We don't always have to start with an ingredient, but we see how we're starting here with 3.5 smoothies. So I start with the unit of smoothie over 1. And I want to know how many cups of bananas. So this is what I'm looking for, cups of bananas. So in my in my bridge here, how I'm going to go from one thing to another, I know that I'm dealing with just cups of bananas and smoothies. Smoothies is on the bottom to cancel out. Cup banana goes on top, and then I go back and, again, what's the bridge? The bridge are the number values in the recipe, and in this case I'm talking bananas to smoothie, so I use the 1 and the 2 respectively, because I know that for every one smoothie that I want to make, I'll need 2 cups of bananas. And so we solve. We say, well, 3.5 smoothies, 3.5 times 2, that gives us 7, again, over 1, which is just 7. So in order to create 3.5 smoothies, this tells me that I'm going to need 7 cups of bananas. 7 cups of bananas is going to be necessary for me to get 3.5 smoothies out of this recipe. So again, if you ever want to multiply a recipe that you have, or if it's not doubling or something a little bit easier of a change than that, maybe it is 3.5 or something like that, then you can use stoichiometric ratios to then figure out how much of each thing you need in relation to each other. So we look at these values, and you can kind of see that this is mimicking a chemical equation, right? We have our reactants on the left side of the arrow, and then we have the products on the right. So we can kind of equate this into what an actual chemical equation would look like down here, where we're going to get these coefficients from our balanced equation. So when we balance this equation here, of course, nothing or blank means 1. We have now the amounts of things in relation to each other, the ratios, and these are actually moles, all right? So this is moles. And remember, moles are very important because they allow us to use a bridge, so to speak, to connect now not just different units to one another, like grams, particles, and volume, but also to substances as a whole. So and again, no different than any of the recipes. We have 1 mole of nitrogen, right? That's the coefficient here, and I'll write that as a placeholder so you see there's 1 mole of nitrogen for every, I'm looking at NH3, I see 2 moles of NH3 from our balanced equation, and this is a mole ratio. You know, the only difference is we're not talking about cups of strawberries or yogurt anymore. We're talking about chemical substances. So for those 2 moles of NH3, well, then how many moles of H2 are associated with it? And we would say that from our balance equation, it tells us 3. So we have this nice little template here that helps us work through that. So doing this the same way, but again, because we have substance A is our known, substance B is our unknown substance, so that's what we want to make sure we're differentiating. And because we're going to go from one thing to another, not just one unit to another, we'll have to make sure that we incorporate that chemical formula there for whatever the substances we're using have. So I see that here I'm starting with 50.50 moles of H2, right? That's substance A. So a lot of the times you can go through and you can circle a substance and you can label it, right? So this is substance A. It's A because I have a quantity that I know, whereas this would be substance B. This is what I'm being asked about, so that's the substance that I want in the end. And these are one-step stoichiometry problems because we're only using one conversion factor, which is these coefficients from the balanced equation here. So this step right here, when we are going from substance A to substance B, this is actually how we got from 1 strawberry or 1 smoothie to 2 cups of bananas, right? It's the same idea. So we're just now using our chemical recipe for these chemical equations. So then we say, all right, well, moles of H2 have to be on the bottom to cancel out. I can get from mole of A to moles of B, and that's going to allow me to get to moles of NH3. And then you're like, well, what are the values? And now this is the case where moles are not always going to be equal to 1 at this step because we have to use those coefficients. So again, the coefficients here are the number of moles for how we get from A to B, right? And we have to be in the unit of moles. So I'm just going to write that too. Must be in moles to go from A to B. All right, it must be in moles to go from A to B. So how many moles of H2 are there based on my balance equation? There are 3 for every 2 moles of NH3. So there's our ratio there, and moles of H2 cancel. And now the biggest change, I guess, from last unit, if you hadn't been doing it already, is that now we're ending with a completely new substance with our unit. So we have to make sure we note that. And so that is what I'm looking for in the end. And then we have 50.50 times 2. So I'm going to do that really quick just to double check, make sure it's all good. I have 101 over 1 times 3, which is 3. And I go 101 divided by 3. That's going to give me 33.67. So there would be 33.67 moles of ammonium, or NH3, based off of how many moles of hydrogen. And with this, just like we would say, oh, we would need 7 cups of bananas to produce 3.5 smoothies. We would be able to produce 33.67 moles of ammonia if we had started with 50.5 moles of hydrogen. So that's how we're associating the relationship between those values and those substances. Another one here, since I have a number for this, this is A. This is going to be substance B. And so I know I start with what I'm given. So we start with 12.5 moles of NH3, which is substance A, times. And I know that at this step right here, this is where I'm going to have to jump from A to B, which is using my coefficients from the balanced equation. Moles NH3 go on the bottom. I have moles of N2 on top. And so now we're kind of working backwards. We're saying, well, what if I want to produce this much of this, right? How much of that other reactant, nitrogen, would I need? And so we use our balance equation. We say, well, for every 2 moles of NH3, it's equal to 1 mole of N2. So I go down here and I put 2 moles of NH3, 1 mole of N2, and then I solve. Moles of NH3 would cancel out, and I'm left with the unit moles of N2, 12.5 here, divided by 2, and we should end up with 6.25 moles of N2. All right, so hopefully this helps you out. You see down here, this is exactly what we had done before in order to go from substance A, which is, again, my known substance, what I have information for, to B, this is my unknown. That's what I want to end with. All right, so work through, and it is very important that you balance correctly so you have the correct ratios to your quote-unquote chemical recipes. So I hope this helps, and work through. If you have questions, always let us know.